Hey guys, and welcome back to another YouTube video. In this video we are going to be continuing on our facial detection app. In the last video we actually created the neural network for our project. So as you can see over here we have this neural network. We had also saved it over here, as you can see. So in this video we will be creating the making the implementing live detection, and in which is pretty simple actually. So we will be using OpenCV in combination with TensorFlow and a few things like that. So the first thing you want to do is import CV2, and we also will need a couple of TensorFlow modules. So we'll just say uh, import TensorFlow as TF. From TensorFlow import keras, and from TensorFlow.keras.models import load model. We will also need numpy as np, and I think this is enough. Alright, so we will define our class names again. I'm pretty much gonna copy that from here. So copy, and let me just paste it over here. So we can now load in the model. Model is equals to keras dot what was it? I think it was just load model, and we will just pass in our model. Alright, cool. So now we have loaded in our model successfully. We also need to put this slash afterwards. Alright, so now what we will need to do is load in the Cascade classifier for the face detection, like actually detecting our face. So I actually have already downloaded the Cascade classifier, but I should have the link to download the Cascade classifier in the description box down below, so you can do that. So I have it saved right here, so it's this one. So I'm just gonna copy that and paste it in my directory, Python projects, and I'll just paste it right here. It's an XML file, so I'll just make a comment loading in the Cascade classifier. So the way we do that is it's pretty simple. All we do is we just say face Cascade is equals to cv2 dot Cascade classifier, and in there we just need to pass in which Cascade classifier we are dealing with, because there are a couple of them. So I'm actually just gonna copy this name since it's a very long name. Is there a copy path? Okay, there we go. Copy path, copy absolute path, actually copy file name. There we go. dot xml. We need to add the dot xml. Next we will load in our model. So I'll just say, actually we already have, yeah. So now we can actually create the while loop for our camera. So actually first we need to define a video capture. So creating the video capture. To do that, we just say video underscore capture is equals to cv2 dot video capture 0. Now if you are using an external webcam, you want to change this to 1, or if you are using a CCTV camera, then you want to use an RTSP protocol, and you want to set this accordingly, and it should be in a string if you are using a RTSP protocol. So I'll just add a 0 over here. Alright, cool. So now we can create a while loop. So I'll just say while true, capture the thing frame by frame. So capture frame by frame. I'll just say ret comma frame, and it should be over here, is equals to video capture dot read, and we want to convert this entire thing to grayscale. So I'll just say gray is equals to cv2 dot convert underscore, actually it is cvt color. So we will convert the color to of the frame to color underscore bg r to gray. Alright, and I didn't add the cv2 thing. Alright, cool. So now we need to actually detect our faces. So faces is equals to the face cascade dot detect multi-scale. In here we will pass in a few parameters, gray, then we will also say the scale factor 1.1. you can play around with this. Min neighbors equals 5. Min size equals 60 comma 60, and flags equals cv2 dot cascade scale image. Cool. Now why is it on like this? Expected argument. Okay, I don't know why this is the case. Alright, so now what we will do is we will create a face list. So I'll just say faces underscore list equals to a blank list, and we will have a list for our predictions. So preds, then we just say for x, y, width, height. In our faces list, we want to say that the face frame is equals to the frame y plus h and x to x plus h. And okay, oops, this should be w. So from y to h, and from x to x plus w. So this is kind of like the way we do it with strings, but we are just doing it with our face. So like we are splitting it, not splitting it, we are just drawing a square in that part. Then we can just say face underscore frame is equals to cv2 dot convert color. I will just say face frame, um, cv2 dot bgr to rgb. So we'll convert this entire thing back to RGB format, and oops, this has to be color underscore. And what else do we need to do? So we will also need to resize it to the format that our model can understand. So I'll just say face frame is equals to cv2 dot resize the face frame, and we will just check the size over here, 200 by 200. Cool. So now we need to convert this to an array. Doing that is pretty simple. We just say face frame is equals to image to array the face frame, and we need to expand the dimensions. Actually, I can basically copy paste the same thing. We are doing what we had done to our model. So doing I won't be explaining you all of this because we have already looked at it in our previous video. I forgot to import this name, keras.preprocessing. Cool. We also need to restack it, so face frame p.restack. What was that? Face frame, obviously. Face frame. Cool. So now we need to append it to our list, which was our face list. So faces list dot append face frame. Alright, so next what we need to do is we need to say actually we need to predict on our faces list. So I'll just say prediction is equals to model dot predict. Actually, I think I should just name it prediction. Sounds better. And we just want to predict on our face frame, and I'll just say print class names np.argmax prediction. And we will need to do one last thing before we actually test our app. We need to actually handle the case for closing the window and actually displaying our video thing to the screen. So let's actually first do that. To do that, we just say cv2 dot imshow. We can just title this as video stream or something like that. Video. We want to display the frame if cv2 dot wait key 1 and 0 times ff is equals to odd q. So if we are clicking on the q key, we want to break out of the loop, and oops, I just the k over here has to be capitalized. Wait key. Alright, and one last thing we will do is we need to actually display we need to actually destroy the window if something like this happens. So we just say video capture dot release and cv2 dot destroy destroy all windows. Cool. Now that was a lot of code that we wrote. but let's test it. So I'll need to change this to main, and actually I think I'm just gonna test it through my terminal. So I'll just go python 3 main.py. Now it does take a second or two for some reason. It needs to actually load in the model and all of that stuff, so yeah. But as you can see, it only took us 49 lines of code to get out of our imports and load in our models and do all of this stuff. We will be adding on a few things, but this is the general idea. There we go, we have loaded in the model, and there we go, we have our first error. Don't worry, we can fix it surely. So okay, so our error is in the min neighbors thing. Okay, so invalid keyword, let's have a look. Hmm. Hmm. Okay, that's kind of weird. I was not expecting to run into this error. You know what? I think we can get rid of the parameters for now. Try it without them. Alright, it's taking up a second. It took a second to load in the model. Okay, face frame is not defined. What do you mean? What do you mean face frame isn't defined? We defined it right here. Okay, I think we spelled it incorrectly or something. I don't know. Come on. I hope it works. Okay, there we go. And there we go. We have our thing. And there we go. Input 0, nothing, nothing, 3. Okay. And that's alright. Let's have a look. So I'm not gonna do this. None 203. Now this is a little weird since we are resizing it as 200 200. So what we need to do 203 and add a 1 there. Alright, let's see if it works. And there we go. OpenCV error, bad argument. Expected length to got length for. Alright. So OpenCV can't handle that stuff. Cool. So what can we do? The thing is, I think the crazy thing is that I'm pretty sure detect multi-scale takes in those parameters. Like, that's the crazy thing because I'm pretty sure multi-scale does take in the scale factor and all of those parameters. So let's try it out again. Maybe it will work. I don't know. Scale factor 1.1. my my neighbors phi min size 60 comma 60 and flag equals cv2 dot cascade scale image. Cool, let's see, hope it works. Also, let's have a look at a model. Okay, so we are loading it as 200 by 200. Cool. And okay. Hmm. All right. This is. All right. Let's try doing something like this. Um. If len of face list is greater than 0, then we predict on face list and we just print it out. Let's see. The crazy thing is I am writing 200 by 200 over here. For some reason it isn't working. And it still doesn't work. Okay. Wait, okay. Let me actually see this. Print face frame. I hope there's a shape parameter with the face frame. Because that's a very weird shape that is being received. Let's have a look. 200 by 200. Then why isn't that working? That is correct. 100% correct. If that is correct, then why is it throwing us that error? Because if I also print out the face frame shape over here right before I do the predictions, I should get that. Come on. Alright. And there we go. 200 by 200 by 3. There we go. So it is 200 by 200 by 3. Found end M3. None 203. So what? Okay, wait a second. I should actually have a look at this. If I just say print train dataset dot shape, and I run net.py, let's see what we get. Pretty sure I will run into an error. There we go. I don't know. Wait, is there like a 0? There we go, and okay. Now I don't care about this stuff. I know that that's working. Okay. I don't need to print it over there. I think I should print it over here. Print image.shape. We don't need it over here. Let's see. Alright, images, no attribute shape. Maybe I can get images.shape over here. Print images.shape. Pretty sure I can call it on something that's converted to an array. Okay, but by the looks of this, there you go. It is 1 200 203. Oh god. Okay, that is right. If I can load it in by a target size of I don't know, none, 200 200 3, none, 200 203. Maybe that might work. I might have to retrain the model again, but I think that might work. Okay, so it at least got none type. If I just load it as 200 by 200 by 3, just get rid of the none. Let's see. Okay, cool. So it didn't throw us any error. So maybe if I can just redo the model thing again, that might work. Comment this out and just save it as v2. Python3 main.py, and let's let this thing train. And I will see you once this is trained. Alright, so I am back. Turns out when I did that, it actually threw me an error, so I just changed it back to the same thing. And I just retyped the code out. Maybe it was some sort of typo. So yeah, so I just retyped it out, and it's now working. Awesome, cool. Let me actually run the code and show you, so you guys can understand it. So let's run it again. Come on. Takes a second or two to load in the model and all. There we go. And we have our predictions over here, as you can see. And we are achieving a decent frame rate. The main reason why this is a little low is because I'm recording right now. If I wouldn't be recording, then this would actually be a really good frame rate. So yeah, we can actually quit this, and I will just go print class names np.arg max spreads, just so we can actually get a better understanding. I understand these numbers what they mean, but not everyone watching this. So yeah, and we are getting like half of the predictions correct. Some of them are still wrong, but we can work with it. All right. There we go. So as you can see, it says person face, person face, person face. So okay, so it is pretty confident that this is my face. Now get this, we are comparing this face against Stephen Hawking's. So technically the model isn't that good, because even though there is so much of variation between the two faces, it's still not 100% right. I'm just have to change this to V1. Okay, cool. So one last thing that we will do before I wrap up with this video is we just want to show it on the display. What was our prediction? Just so it looks a little good. Now this is like an optional part. You don't need to do this. And also this is something that I will be trying out because I kind of forgot the syntax. So let's say label is equals to this. And okay, now how do we do this? Okay, I think it was cv2 dot put text or something like that. cv2 dot put text on the frame. The text should be the label at x comma y 10, and we will just say cv2 dot font. What was it? I think it was Hershey Simplex. Okay, so there are like many fonts. 0.45, and I think we are gonna keep it red, or I don't know. So let's make it 255.00, so that's red, and 2, and we will also just draw a rectangle around the face. So I'll just say cv2 dot rectangle, oops, rectangle frame x and y, x plus w, y plus h, color, and actually this will be our color red. 255.0. There we go. Now let's run this, see if it works. Come on. Takes a second. There we go. And okay, 942 expected something. Okay, so maybe we have like some invalid color argument or something like that. Maybe I don't know what type of a color we need to put in. Alright, so if I just pass it in like this as color, and I just have color over here, and I can just define it up top as 255.00. Will this work? Let's just open. Come on. There we go. Alright. And come on. Put text. Let's actually comment this out for now. See if at least the rectangle thing works. There we go. uh, okay, there you go. As you can see, my face is being detected. I can move around a little bit and it is still able to detect my face, which is pretty cool. Alright, so I'm just gonna quit this. Quit. Come on. And why wasn't the put text thing working? Not working. Oh, oops. This has to be a minus sign. Mistake over there. Little mistake. Come on. And actually, okay, oops, I actually realized one more thing. CV2 works BGR, not RGB. So technically, this is blue, green, red. So I need to say 0, 0, 255. Cool. This. So only then I will actually have the red box, and otherwise I will have a blue box. Although I will be expecting red. Alright, come on, let's just hope that this works. Then that will be fantastic because we will have our entire interface in place. There we go. And default face. Okay, that is an incorrect prediction. Let's see if we can get it to change. Because that actually shouldn't be default face. Wait. Let's quit this. Let me print out the label first. Cool. Python 3 main.py. Come on. There we go. Alright, okay. Why is it default faces? Should not be that. I at least know that the model is working. That's okay, so we did get one person face prediction. Wait. I wanna check one thing. So we're getting a few person face predictions over here. Come on. Okay. If I were to just print out the predictions, what would that give me? 0, 1, 1, 0. Understood that. Come on. There we go. 1, 0, 1, 0. Okay, so it is getting a couple of person faces, which is pretty cool. Come on, get me a person face. It did get me a couple of them earlier. Okay, there we go. As you can see, it was switching between default and person face, which is cool. So there is a little bit of stuff going on over here, as you can see. All right, let's get Stephen Hawking out. Maybe this prediction can be correct. Gotta arrange him in front of the camera, I guess. Default faces. Can predict Hawking correctly, but can't predict me. There we go, as you can see. Stephen Hawking. Alright. Well, expected a bit more. I thought I thought that Stephen Hawking would be predicted incorrectly, but alright. So there we go. Not the most accurate again. I will improve the accuracy of camera. I won't be